So there's this sign that's hanging, and it's still, and I want to know the two forces of tension within the ropes. So I'm going to label them Ft1 and Ft2, and I also know that the sign has some mass, and it's causing a gravitational force downward. And I'm going to use torque in order to figure out Ft1 and Ft2. So the sign is still, so I could say this: the sum of all the torques is 0. And I could say this about any location, any axis of rotation, because if I pick any axis point, the sum of the torques will always be 0 because the sign is still and not rotating around. The key to picking out a good axis of rotation is that you want to eliminate one of the terms, specifically one of the terms that you don't know. So I'm going to choose this Ft1 spot as my axis of rotation and sum up all of my torques. Recall that the torque equation is Fr, so I'm summing up all of my force distances from the axis of rotation. The first one I get to is this weight force. Now, sum up all my torques. Let's see. I'm going to have weight times, well, how far away is the weight force from this far left end? That must be 0.5 meters, half of the total length of the sign, because the gravitational force acts right in the center of mass. So that's W times 0.5. I'm going to actually use fractions here and say instead of 0.5, I'm going to use half a meter. Is that positive or negative torque? Well, things that rotate this way I'll call positive, things that rotate that way I'll call negative, so this must be a negative torque that's happening. Let's see, I put my pen down, I apply the force downward, and yes, it is a negative torque. The next thing that I come to is Ft2, so let's put that down. Ft2 is my force. It's 0.75 meters away from, so 3/4 meters away from the axis of rotation, and that must be, well, that looks like it's a positive torque. Those are the only torques that I have to consider because this Ft1 is right on the axis of rotation. I can ignore it and set all of that equal to 0 because it's still. Let's solve for that Ft2. Well, I can move this term over to the other side, and I get Ft2, 3/4 Ft2 equals 1/2 W. And I can move these numbers over to the other side by multiplying by 4, dividing by 3. So I get Ft2 is 4 over 3 times over 2. And W is the weight of the sign. So what am I left with? I have 2 over 3 W. So 2/3 of the weight is held in this tension force. You could probably reason at this point the Ft1 force, but let's walk through it like we would if we were, say, instead of summing up all the torques, now let's sum up all of the forces because we know that should also equal 0 because the sign is still. I have two forces, Ft1, Ft2, I'm calling up now to be positive because I'm looking at a different thing. Now I'm looking at forces instead of torques. So I've got these two that add up, and I've got a weight that's going down. All of that is equal to 0. So Ft1 must be weight minus Ft2, which is weight minus, I just solved for this, 2/3 weight. I could write this in a simpler form so that it makes sense when I'm doing this fraction subtraction. I could say 3 over 3 W minus 2 over 3 W. And what am I getting for Ft1? Well, that is 1/3. So the final answer is Ft2 is holding 2/3 of the weight. Ft1 is holding 1/3. All right, so long.